Yeah, recording is started. Okay, please respond to your attendance. Adi Lakshman,
Present, sir.
Amit Sarvani,
Present, sir.
Amit Kumar 046,
Present, sir.
Ankati
Yes,
Vignesh,
sir. Present.
Ankati Vignesh,
Present, sir.
Ankit Karikita, present. Is he there? Ankit, अंदर के भाग गया. Ankit is not there. Ankit Karikita, आशीष कुमार तिवारी, आशीष तिवारी, absent. अशोक कुमार,
Present, sir.
विश्वजीत बेवड़ा,
Present, sir.
बिरला क्रांति,
Present, sir.
चेतन अजमेरा, absent. देवाशीष बेहरा,
Present, sir. Present, sir.
yes. गुगलोतो देव सिंह,
Yes, sir. Present, sir.
हरी संगोत, present. Some problem with his mic. Harish, what's the problem? Your voice is not audible. Harish? Okay. क्या हुआ हरीश? Some problem with your mic. Raise it, correct it. हर्षवर्धन सिंह, हर्षवर्धन सिंह, सुपी प्रसानिया,
Present, sir.
जगदीश जैन,
Present, sir.
जिगर,
Present, sir.
कुणाल अरविंद, कुणाल अरविंद is absent. मनदीप सिंह गिल,
Present, sir.
मंडलिक प्रज्वल, मंडलिक प्रज्वल, absent. मोहित कुमार, absent. नितेश रजवाड़े,
Present, sir.
नितिन आनंद,
Present, sir.
पंकज दास,
Present, sir.
प्रशांत कुमार प्रजापति,
Present, sir.
प्रियांशु,
Present, sir.
राजेश कुमार,
Present, sir.
राकेश अतला,
Present, sir.
श्री चंद्र बेहरा, absent. सतवर्त नायक,
Present, sir.
सौरभ कुमार,
Present, sir.
शुभम पटेल,
Present, sir.
शुभम कुमार दास, शुभम दास absent. सिद्धार्थ उर्मिलिया, सिद्धार्थ कुमार उर्मिलिया absent. सौरभ आनंद,
Present, sir.
सुजीत गुप्ता,
Present, sir.
मुकरर सिद्दीक,
Present, sir.
योगेश कुमार बेंडल,
Present, sir.
आकाश पवार,
Present, sir.
अमन अग्निहोत्री,
Present, sir.
देवांशु वर्मा,
Present, sir.
कुणाल कुमार गुप्ता,
Present, sir.
कुंदन कुमार राय,
Yes,
कुंदन
sir.
कुमार राय present.
Yes, sir.
राजेंद्र कुमार सिंह,
Present, sir.
रजत कुमार,
Present, sir. भाई सॉरी यार भाई क्या है
अमन अग्निहोत्री, प्लीज स्विच ऑफ योर माइक. अमन,
Yes, sir.
प्लीज स्विच ऑफ योर माइक. रजत कुमार,
Present, sir. Present.
संजीव कुशवाहा,
Present, sir.
सोमनाथ रे,
Yes, sir.
वैष्णवी,
Present, sir.
वकास इम्तियाज प्रेजेंट. अच्छा, इसमें अंकित के डेटा का कुछ इश्यूज था. रिपीट द अटेंडेंस अगेन. टुडे इज 49. अंकित का डेटा प्रेजेंट. दूसरा माइक का. आशीष तिवारी इज एब्सेंट. चेतन अजमेरा, चेतन अजमेरा इज एब्सेंट. हर्षवर्धन सिंह,
Present, sir. Present.
पुनः अरविंद एब्सेंट. मंडली प्रज्वल, मोहित कुमार,
Present, sir.
श्रीचंद्रन बेहरा,
Present, sir.
शुभम दास.
Present, sir. Present, sir.
कहाँ है शुभम दास?
Yes, sir.
हाँ. सिद्धार्थ उर्मिलिया, सिद्धार्थ उर्मिलिया एब्सेंट. राइट. So attendance is complete.
सर शुभम अभी भी एबसेंट ही है उसमें.
शुभम
सर शुभम एब्सेंट हो गया. दास.
डिलीट नहीं हुआ क्या?
शुभम कुमार दास.
शुभम दास प्रेजेंट है. ठीक, थैंक यू.
सर पुनः अभी डाल दो.
पुनः अरविंद आ गया.
हाँ सर नेटवर्क इशू था.
चैट में लिख दिया करो भाई. अभी लिख रहे हो. मंडली प्रज्वल अभी आया है नहीं? नहीं आया. उर्मिलिया, सिद्धार्थ उर्मिलिया नहीं आया. ठीक. अब अभी ठीक है अटेंडेंस? That
Yes,
is
sir.
why I normally present the screen so that you can also see कहाँ absent present लगा है. अभी today we will be discussing about practical, that is the triaxial test. Okay. So in the quiz also you have attempted a question on this failure criteria. Okay. In which the failure criteria line was given, and then you need to find out whether a induced stress around the excavation is below this line or above this line. So you get a condition for the stability of that point. Okay, now in the laboratory, how do we determine the axial stress versus confining stress in mirror? That is done by schematic diagram here. Yeah. Schematic diagram is here. You take a sample Okay, and then you provide the confining stress by a fluid, high pressure fluid, by confining the sample from all the sides, and then you provide a uh, axial stress onto the sample, and then it breaks. Okay, so what you have to do is you have to take at least 3 samples for testing, but the standards, whether it is ISIM or IS, they recommend for at least 5 specimens to be tested. Okay, so what you do is you provide a confining stress of, say, for example, 10 MPa, then here it is 35 MPa, here it is 45 MPa or so. Okay, and then uh, below these levels also 3 MPa or 6 MPa or so. So one of the samples, say for example, you have provided a confining stress of 3 MPa, it breaks at some point. So that point is noted, and that is somewhere near, say for example, 85 MPa. So that way you plot the lines, and then you try to get a regression curve, and from that regression curve you draw the line, and that will give you the curve for the failure criteria. And if you know the equation, if you have carried out the regression, you will be able to know the equation of that line. So that's the basic purpose for determination of triaxial compressive strength. And finally, the output what you get from this is your C value of C and phi, apparent cohesion C and the friction angle. Okay, and here M and B are two constants which you are getting from this curve, sigma 1 versus sigma 3 curve. Okay, M is the slope of this line, and B is the y-intercept, or the intercept around the axial stress. Okay, now how do we do it in the laboratory? I'll show you the video. Okay, and in fact,
सर कंपाइनिंग प्रेशर क्या होता है?
बताते हैं, ये वीडियो में समझा देते हैं। कंपाइनिंग प्रेशर से पहले कॉन्सेप्ट थोड़ा सा समझ लो। सर्कुलर एक्सेलरेशन के हिसाब से ही समझते हैं। This is your circular acceleration. You have sigma yy and sigma xx as the boundary stresses, and at a distance r from the center and at an angle theta, you get a value of sigma 1 I comma sigma 3 I, that you can find out as a principal stress at any point. Okay, so here what is happening is that this sample, small element, you can take it as this sample. Okay, and this sample is loaded by two sides with stress sigma 1I and sigma 3I. Okay, so this is known as your confining stress. राइट, इसको एक तरह से और देख सकते हैं। Say for example, if you take one element here, what is happening? What you get is at the skin of the boundary, sigma r will be equal to 0 as per Kirchhoff equation, if you see. Okay, and sigma theta will have some value. Okay, this is it, sigma theta. So here what is happening is that the rock is in the state of uniaxial compression.
Sir,
Okay. Yes, tell me.
sir, what is sigma RR and sigma theta theta?
Have you studied this in your BTech?
No, sir.
No. Okay. Let me find out the lecture material. If it is there, I'll show you. Otherwise, वहाँ से बेस बनेगा ही नहीं आपका. You are from Trust or from mining?
Trust, sir.
Trust. Okay. Civil engineer.
Mechanical engineering, sir.
Then तब तो बताना पड़ेगा भाई. How many are mechanical engineers in this batch? चैट में डाल दो तो गिन के बताओ तो कितने लोग हैं चैट में डाल के. तब तक मैं इधर देखता हूँ. Theory of mechanics. Wait. It's the question किया क्या है? फेलियर क्राइटेरिया हम लोग पढ़ेंगे चैप्टर में, बट why we require this triaxial strength, that is important. बहुत dirty है. This picture is very dirty and I have to write many things. Okay, anyway, I will not make it dirty further. So this is the tunnel which we had seen. Kird's equation is given for a condition in which you are excavating a tunnel and your boundary stresses are or the in situ stresses are sigma xx. Pre-mining stress at this location was sigma xx and sigma yy. Okay, and then if your tunnel has a radius of a, then at a distance r, you can very well find the stresses, components of the stress. Okay, so you are a mechanical engineer, so you must have read solid mechanics and you know what is principal stress, what is shear stress, etc. Isn't it?
Yes, sir.
Right. So, so this is my tunnel. Okay, and far away, 5 times the dia of this tunnel, these stresses are applied. Okay, and if this is P and this is Kp, then Kids gave an equation to determine the stress components in cylindrical coordinates. Okay, so in a cylindrical coordinate, if you take a point at a distance r from this center, okay, so your theta is increasing in this direction. So the components of the stress sigma theta is in the increasing direction of this angle. Okay, and sigma RR is the compressive stress which is acting in the increasing direction of the radius. And sigma r theta is the shear stress that will be there on this small element. So this element has been magnified here. Okay, in fact it's a very small element. And in fact, whatever the deliberations we did in our lectures in the last class, okay, trust people are not there in my lecture now. Okay, anyway, then this state of stress is always expressed at a point. Okay, and at this point, your element, if it is looking like this, then these are the components of your stress, right? And this sigma r can be given in terms of the boundary stress P, this value P, and this value K. Okay, and the radius of the tunnel A. Okay, and at this distance, at a distance r, and at an angle theta. Okay, what is the value of the component sigma r and sigma theta theta and tau r theta? Right. So in this equation, if you put r is equal to a, put r is equal to a in first equation. So what is happening here? This first term is 0. Here also the second term bracket term will become 0. So that means sigma rr is 0. Okay, so at this boundary of the tunnel, my sigma rr is equal to 0. But sigma theta theta, that means this value, sigma theta theta is in the radial is in the increasing direction of that angle. So now here, even if it is r is equal to a, so this becomes 2 and this term becomes 4. So this sigma theta theta is not vanishing, right? So you have some value sigma theta theta here, right? And what about tau r theta? Tau r theta is again when r is equal to a. So this is 2 plus 1, 3 minus 3 is 0. So tau r theta or sigma r theta or the shear stress is also 0. So effectively what is happening here is any element at the skin of the excavation is loaded only in one direction. Okay, that means your rock specimen is loaded only by sigma theta theta and not by any component. Right. Now, let us say the same thing. Is there an example? Yeah. So in this equation, we have done it for this at infinity. What will happen? That exercise we have done.
सर
1 minute, 1 minute. Yes. क्या doubt था?
सर डाउट ये था कि जो सिग्मा थीटा आर आर है वो रेडियल है और सिग्मा थीटा थीटा आई थिंक टेंजेंशियल है, तो सिग्मा थीटा क्या है सर, वो क्या डिनोट है?
Sigma theta theta. This
सिग्मा आर आर था तो रेडियल है,
sigma
सिग्मा थीटा
sigma
थीटा जो है
r
सर वो
is
टेंजेंशियल हो गया और
radial stress, radial component of the stress. Okay, sigma theta theta is known as the tangential. And sigma r theta is known as your shear component of the stress.
सर कहीं कहीं पे क्या इंटरचेंजेबली हम लोग यूज करते हैं शियर स्ट्रेस और टेंसिल स्ट्रेस को,
नहीं
ऐसा होता है क्या?
नहीं, strictly speaking, this is in your cylindrical coordinates. ओके, कार्टेशियन कोऑर्डिनेट में देखोगे आप, ये कल के लेक्चर में पढ़ना है, अभी पढ़ा दे रहा हूँ, बता दे रहा हूँ। ओके, this is your tau xy. So your components of the stress can be written as sigma, चलो इसको सिग्मा ही कर देते हैं, सिग्मा xx, सिग्मा yy, सिग्मा नहीं टाउ यूज किया है, टाउ xy। ओके, so these are the things, और इसको आप प्रिंसिपल कंपोनेंट निकालोगे तो ये सिग्मा 1 सिग्मा 3 और ये 0 0 हो जाता है, ठीक तो करते हो आप फाइनली। ओके, so in Cartesian coordinates these are also known as shear stress. Okay, this and this are known as shear stress components, and this diagonal ones are known as the normal component. Okay, so
Sir,
yes,
you draw some arrow marks for the shear stress, right? Up, down for this component. Can we find this negative or positive from these directions by seeing this notation?
in rock mechanics convention, this down is taken as plus, up is taken as minus, and this compression is taken as plus. Whereas the mechanical engineer, he will do just the opposite. Okay, mechanical
Sir, for
engineers
shear,
take, see for
for
rock shear, yeah, it is on this plane. Okay, if it is down, then it is positive. So this is negative. Is it clear?
Sir, for positive, above is positive.
Above is negative. Above is negative in rock mechanics convention. Mechanical engineers will do it opposite. Why it's there? Because see, all the stresses are compressive in nature in rock mechanics. So every time compressive stress को negative ले लेकर जब calculation करोगे तो बहुत सारा negative दिखता है, which looks awkward. That's why the rock mechanics people, they have preferred that we take the compression as positive and this one as negative. Okay. Whereas mechanical engineers, what they deal with a lot of tensile stresses. So they treat the tensile stresses as positive, so that in their calculations all positive numbers will look good. Okay, that's the convention. And if you see the software, few of the softwares, your compressive stresses, if you do for any excavation, finite element software especially, they will show you negative as the compressive stress because those codes are developed in line with the mechanical engineer's convention. So their compressive will be negative. But when you study the rock mechanics in any textbook, they will treat this convention. ओके कहाँ से कहाँ आ गए भाई हम लोग स्ट्रेस स्ट्रेन में घुस गए जाना था यहाँ तो ये कॉन्सेप्ट जो था यूनिएक्सियल कंप्रेशन के स्टेट में है अराउंड द एक्सकेवेशन नाउ से फॉर एग्जांपल यू मूव दिस साइड 45 डिग्री ये चीज एक इंफिनिटी के लिए हम लोगों ने सॉल्व किया था व्हेन r is infinity and theta is equal to 0 and when theta is 30 degree that we had found sigma r sigma theta r theta from this. Okay. When r is not infinity, okay, then you get some amount of stress. Okay, and that stress will be having some magnitude, and with that magnitude, you can always find the principal components. Okay. So what is happening around this excavation is that at this position, your sample is loaded with sigma 1I and sigma 3I. Two stresses are acting. So here it is strictly speaking, it is a biaxial state of stress.
सर इस एलिमेंट पे शेयर भी लगा हो
शेयर जो लगा है उसको हटा दिए तो आप फिर से वहीं आना पड़ेगा तुम लोगों को बताने के लिए ये एक पॉइंट पे आपको शियर स्ट्रेस और नॉर्मल स्ट्रेस दिया हुआ है
सर तो
उसी
प्रिंसिपल में
पॉइंट
कन्वर्ट
का
कर देंगे
प्रिंसिपल
समझ गए
कंपोनेंट आप निकाल सकते हो
ये सर समझ गए
ठीक है तो हम ये बोल रहे हैं कि जो भी कंपोनेंट लगा होगा ये थोड़ा सा आपका ये एलिमेंट थोड़ा घूम जाएगा ओके तो यहाँ पे आपका ये जो लोडिंग है ये बाईएक्सियल स्टेट ऑफ स्ट्रेस है and when it is a 3D when you're so this equation basically he did it for a 2D analysis. Okay, and in case of 3D analysis what you will get is that you will get a triaxial state of stress. Okay, in 3D. But your failure is governed only by major and minor principal stress, and intermediate stress does not play a role. ये कन्वेंशनल रॉक मैकेनिक्स का कॉन्सेप्ट है कि योर out even if it is your principal stress was sigma 1 sigma 2 and sigma 3 in 3D state this is not going to play a role only 1 and 3 will play a role okay so that's why we are concerned more of this now you tell me इससे 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 पहले एक मैं इसको कंक्लूड करने से पहले एक चीज़ और बता दूं however recent research states that sigma 2 also plays a role. But as far as practical considerations are concerned, sigma 1 और sigma 3 के failure से आप जो भी निकालते हो that is more than enough for अंडरस्टैंडिंग द फेलियर ऑफ द रॉक। जब रॉक बस्ट के केसेस में आप डीपली इन्वॉल्व होगे, then the role of sigma 2 plays an effect, and there the research component is there. Okay, अच्छा, और अब यहाँ ये अब आपको समझ में आ गया कि एक्सकेवेशन के नज़दीक में द रॉक इज ऑलवेज इन द स्टेट ऑफ यूनिएक्सियल कंप्रेशन, बट as you go farther away, the rock is in the state of triaxial state of stress or triaxial compression. Okay, now tell me, if I apply 5 MPa and the rock breaks, but if I compress this rock by 2 MPa and still apply 5 MPa on the same rock, is it going to break?
No, sir. It
No,
needs some more pressure.
it needs some more pressure. This is what your failure criteria requires. So what you have done is, one side you have a sigma 1, other side you have a sigma 3. Okay, so when sigma 3 is small, the rock will break at a smaller compressive load. Now on the another sample, you increase the sigma 2, so this is 1 MPa and this is breaking at say 5 MPa, and now you load it at 2 MPa. So it is going to break at a load higher than 5, and let us say it is breaking at 7 or 8. Okay, 7 or 8 MPa. So that way you go on testing and few more specimens. Okay, go on increasing the confining stress, less side stress. Okay, and that is known as the confining stress. So confining, why we are calling it confining? Because the element here is confined from all the sides, and because of the confinement, this rock will require more value of sigma 1 to break. Okay, whereas here there is no confinement, it is under uniaxial compression, so it is breaking easily. Okay, and this is the way you try to find the curve. Okay, so the Mohr-Coulomb curve says it is a straight line. Other authors, they will say no, it is a non-linear line. Okay, so many people have given curve for this failure criteria. Okay, right. So this is the thing we have to find out, and in order to simulate this confinement, we need a setup in the laboratory. So that setup we will see how that setup is made. Okay. Now is that concept clear? Why? What is confined stress? How the failure is governed?
Yes.
Right. So as we go away, the rock is under triaxial state of stress. Okay. Triaxial state of stress in general. Okay, and there the failure of the rock will be difficult, whereas near the skin of the excavation, the failure of the rock will be is liable to be more. Okay, if the strength of the rock is very high and this induced stress sigma theta theta is very less than the UCS, then there will not be a failure. Here also there can't be a failure. So your pre-mining stress state, the size of the excavation, and the strength of the rock. These three data will tell you whether there is going to be any failure at the skin of the excavation, or up to what depth the failure will be there. Okay, sometimes the failure can be up to this depth also, like this. Okay, so this is depending upon the failure criteria, and failure criteria or the strength of the rock can be determined from this curve. Now is the concept clear?
Yes, sir.
Okay, that's the basic application of the triaxial state of stress. बहुत फंडामेंटल में मैं बताया. In fact, in the theory classes, I go for more number of lectures. So in theory, you will be. Should I save this? Save करें या
Yes, sir. Same.
save करके दे दें?
Yes, sir. Yes, sir.
File, export as PDF, basics. Basics of triaxial stress. Okay, so I think it's saved. Come out. सेव हो गया ना? हाँ, it's saved. Keep it here and come out of this. Right. So how do we do the experiment? So what you require is basically bring machine to know the density of the rock. You need a specimen. Okay. And this is known as the triaxial jacket and the loading plugins. We'll see how these things are used. Okay, this and you require measuring tape, and this is your hook sail. Okay, it is nothing but a hollow cylinder, okay, through which you can place the oil. And when you place that hook sail, that rubber thing which you have seen, it will form a jacket, and then it will be able to provide load onto the specimen. And these are the covers for covering the thing. So this, in fact, this setup was designed by Hook. That's why it's also known as a hook sail or a biaxial chamber. Because why we call it biaxial? Because we are applying sigma 2 on all the sides and sigma 1 from the top. Okay, so two axes only the stress is there. Okay, a little bit of more you will see. Okay, so they weigh the rock to know the density, right? And if you calculate its length and diameter, then you can find the volume. From after the volume, you give you the density. That's why it's required. Okay. So ठीक है, ये मेजर कर रहा है. That is additional data. Length measure कर रहा है. Okay, and this is your hook cell. Now inside this hook cell, you have to place the specimen. And from outside this jacket, if you pressurize it through oil, then you are able to give a confining stress onto this. So that sample, this is a hollow. Okay. These are the two holes through which oil can be pressurized. Okay. This is for pressurization and this is for venting out the air from the cell when you are filling the oil. Right. So this hook cell they will first fix it into this jacket. This jacket they will first fix it into the hook cell. And you see how tightly it will go. एक साइड से बंद कर लेते हैं पहले. Then we place this jacket inside it. It's going like a piston. Okay. Right. There, fixed it. Right. Now you see, if you inject oil, what will happen? Between the cylinder wall and between the jacket, oil will be filled. And if you pressurize this oil, what will happen? Because of that pressure, this rubber jacket will come out. So the rubber jacket should not come out. That's why we are placing a cap here. Okay, so after that they will place a cap over this. लोडिंग के लिए नीचे से प्लेटन दे देते हैं. Pattern they are showing here. Okay, then over this they place the specimen. Then they close the cap. So right, this is the way they have fixed it. Fix the specimen. Then they will place the cap. So this cap will cover the jacket, rubber jacket. So now whatever pressure you give, it will not come out, and it is going to compress the rock inside. Okay, so this is the way you are providing compression confinement to the specimen, and from the top you can provide an axial load, and this spherical seating especially made so that even if the machine is not axially centered, this spherical seating will center the load. And now what you do is you have to place this hook cell onto the compression testing machine. Okay, and this is your load cell to know how much load is coming onto the specimen. Okay, so they will place this hook cell over the load cell. Right. They will try to lower the platen so that it just touches the critical sitting area. So it should just touch the area. So this is the hose through which they will supply the oil and they can maintain the pressure. Okay. So now what they have done is through this hose they are pumping the oil inside this, and this tap is opened, and whatever air is there that will come out, and then it will fill the complete jacket, and then oil will start flowing. The moment the oil starts flowing, you close this valve, and then you can pressurize this jacket with the pump. Okay, so here they are venting out the air. So this is the pump through which this hose from the hook cell is going through this pump, and then through this pump we will send the oil into the hook cell. Okay, and we can maintain a constant pressure of the specimen. confinement का constant pressure हम maintain कर पाएंगे. Okay, and this knob what he is touching is used to control the flow, and there is a pressure transducer to measure how much pressure has been provided onto the hook cell. Okay, and this pressure transducer is then sent to the data equation. Yes. Okay. So he has opened the valve. Now he will switch on the motor pump. In fact, in place of this, you can use a hand pump also. So they're sending the oil. Now oil has started flowing. They will wait for a little more time so that completely all the air bubbles are driven out. Now they will close it. Okay. And here, now they will increase the pressure. So that increase in the confining pressure can be seen from the data acquisition system also. Okay. Load and pressure. These two things will be monitored. Okay. Confining pressure. Okay. This data acquisition part we had discussed in Excel compression. Same things are there. Okay. Then you have to go for logging. Okay. तो फास्ट करते हैं. Okay, now they are increasing the pressure in the hook cell. That can be seen from this graph. Okay, blue is the pressure in bar. So the first experiment will consider a value of 10 bars. Okay, so how much? 10 bars. That is 1 MPa pressure they have given. Okay. Ten bar दिया ना, हाँ, 10 bars. And then now they will start this loading machine for providing the axial load. Okay. This is now
Sir, 10 bar.
maintained constant, 10 bars. Blue one is your confining stress, and now they are increasing this axial load. Okay, load that is given in kilonewton. Okay, it will go on increasing. I'm increasing the speed. Okay, so this has taken the load. The load it is taking now. Oh. Anyway, that we could not capture the failure. So at the time of failure, your this axial load will go on increasing, and then it will reduce suddenly. Okay. So axial load versus time curve was there. Okay, so what will happen? It will go on increasing, and at the time of failure, suddenly it will drop. Okay. So this point has to be noted down. What is the load at which the specimen has broken? And this 10 bars was decided by you. Okay. So what you have got is sigma 1 versus sigma 3. Say for example it is 20 tons. Okay. And based on your this thing, uh, dia and other considerations, let us say it becomes 5 MPa. Okay, that is the axial stress. So axial stress at which the sample broke is known as the axial strength. Okay, so your strength is 5 MPa and sigma 1 is 1 MPa. So for this curve, you got from one specimen, you got the point 1 and 5. Sigma 3, sigma 1. Okay, so sigma 3 is 1 and this is 5. So this point you got for your curve. Similarly, you will do test for another curves. Okay, and once the specimen is broken, you can now remove the things. Then you can uh, take out the sample to see how the fracture has taken place. So removing the sample is also a very difficult task. See how difficulty they will have in removing this sample. While inserting it was very easy to insert it. Now while removing it is very difficult. That's because the rock has broken along a plane and its volume has expanded because of the breakage. It's difficult. खड़ा भी हो गया तो नहीं निकल रहा. Okay, so he will do some other arrangement. थोड़ा वो निकला. नहीं निकल रहा. यहाँ भी डाल के देखा नहीं. खींचने का कोशिश कर रहे हैं. निकल जाएगा. Okay, now the system has come out. And you see how it's broken. Okay. Now you see the angle at which the things are broken. Okay, so this angle, that is a beta angle, that is when you study the failure of the rock, that time we will see that this will be not 45 degree, it will be different than 45 degrees. Okay, so this is a perfect shear failure of the rock that we are seeing here. Okay, in triaxial compression. So if you remove other part, it will be like a cone. ऊपर वाला part ही निकालेंगे देखो. दो दो सेम एंगल के साथ एक फ्रैक्चर हुआ है. Okay. It is something like this. One fracture angle is like this, another fracture angle is like this. Okay, and this is your beta angle. And here, this portion will look something like a cone. Right. Right, so this was the chemical thing. यहाँ पे डेटा नहीं आ रहा है. Let us see. आगे डेटा दे रहा है क्या? This is a part of another video. Anyway, so that's the way you find the ये normal load at the time of breakage. Okay, let me see that value. Anyway, that value I will give you from the Excel. Okay, procedure is only shown in this video. Now see, this is known as the for each sample. For the next sample you can do, for the third sample you do this and then you find the curve. Another method is known as the multi-failure. Multi-failure analysis नहीं बोला, multi-failure triaxial test. So what is happening here? is axial load, and blue we can say as confining load, and this is your term. Okay, so what you have done is you have increased first the confining load and then you have kept it constant. Right. Now, after that, you are increasing your axial load. Okay, and then just at the time of failure, the moment it is going to drop a little bit, immediately what you do, what happens is that your this confining pressure also starts increasing. Okay, this happens because this is your specimen. Okay, and from this side it is having fluid under pressure. Okay, the fluid is under pressure. The moment there is a generation of the crack, now what will happen? There will be a movement along this crack, and because of this movement, there will be these cracks will have asperity, sawtooth type of feature. Okay, and because of these asperities, the volume of this rock will increase. And since your oil was filled here and it is trying to increase the volume, what will happen? It will increase the pressure of the fluid, even if you have not increased it. Okay, so at that time, if it is increasing, you bring it, the moment there is a failure, going to be a failure, you bring this to another level, you start pumping fluid into this and bring it to a level of, say if it was 1 MPa, you bring it to a level of 2 MPa. Now this failure जो यहाँ पे आके आ रहा था, ये मूवमेंट रुक जाएगा अगेन कन्फाइनमेंट बढ़ने के कारण. So again it will start picking up the load. Then again it will start dropping. The moment it starts dropping, you again increase it to a third level. Okay, and then you go on increasing the load. Okay, so what is happening is that with a single specimen itself, you get multiple failure points. Okay, so suppose this failure was 5 MPa, this failure was at 15 MPa, this failure was at 20 MPa. Okay, and this is the curve. So with a single experiment itself, you are getting a curve for sigma 1 versus sigma 3. Sigma 3 was 1 MPa, that is 5. So 1, 5. Another is 2, 15. Another point you got 3, 20. And then you can get a curve. Okay, so that first experiment, whatever video you have seen, was for the single failure triaxial test. In the one go itself, the failure was seen. But if you want to, if you have very less number of samples, you can go for multi-failure triaxial test, and then you can find out the failure curve from the single sample by using this multi-failure test. So in the video, we have shown one video for multi-failure test also. So in one of the specimens, this was kept at 10 bar, another 25 bar, another at some intermediate value between 25 and 50, and another value something greater than 50, and another between 60 to 75. So one level, two level, three level, and fourth level. Okay, fifth we were trying to do, but the sample broke away. So at least 1, 2, 3, and 4. Four points we were able to get from a single sample.
Sir, what is point index here
Point in the where?
in x-axis?
That is the time. In fact, while making this calibration, they might have forgot to remove this. These are all user-defined things. Okay. So in fact, this is the time in seconds. Okay. So this in the experiment, what I told you that you are basically logging it on two things: axial load through red, confining load through blue, and this is your time. Okay. So by mistake they have forgot to rename it as time. Okay. So in the data logger, you have the options to mark the points also. Okay. So y is your x is your 16,589 seconds. Y is your bar blue line. So that is 10 bar. Okay, 25 bar, 35 bar, and 35 bar, then 55 bar. Here at 1600 time, it was 122.8 kilonewton, 149.57 kilonewton, 157 kilonewton, 170 kilonewton. Like that, you can get those data from the data acquisition system also. Okay, so this is showing you the complete view of what has happened with a single sample in multi-failure analysis. Okay, and after the multi-failure analysis, let me show you what happened. We wanted to conduct more tests. Oh, okay, we wanted to conduct more tests beyond this, but controlling the confining stress was a bit difficult at this point. So we could not get anything and the sample broke completely. Okay. So the moment a failure is initiating, you have to take action immediately to increase this load. Otherwise, it is very difficult to maintain a multi-failure experiment. Okay, so after the experiment, they are trying to remove the specimen. Okay, now here you can see the kind of failure. एकदम clear cut, two planes you are able to see in the failure. Okay, this was a very slow rate of loading. Okay. In fact, you can take out the things and see they have to hammer it a little bit, because the failure had initiated, but complete failure has not taken place. And here you see on the top, it's just like a cone. Okay, they will hammer a little bit so that this failed thing can be removed out. Okay, here are two planes of failure you are able to see. Okay, a perfect shear failure. Okay, and then by using this protector, you can find the angle beta, and then you can even draw the more circles. Right. So that's the experiment. And coming to the data and its analysis, a linear regression. This experiment, we try to do it for a low confining stress. Okay, low confining stress of 1 to 5 MPa only. 10 bar, 25 bar, 35 bar. Okay, and then 55 bars. Okay, so this table is showing you the confining pressure that you have maintained, and here this is the breaking load in kilonewtons that you have got for different samples. Okay, and the moment you know the dia and the area, then you divide it by the area, and then you find the breaking strength in MPa. Okay, so this is breaking strength is sigma 1, and this confining pressure is sigma 3. So for making the graph of sigma 1 versus sigma 3, we took the same data here and made the graph. Now what you see here is that at low confining stresses, the slope of the line is very high, and as you go on increasing the confining stress, the slope becomes shallow. Okay, so this is something like the same curve which what you see here is that at low confining stresses, it is having a high inclination, and as you go on increasing the stress, then this becomes saturated, a straight line. That is the funda of the concept given by Hook and Brown. In fact, this Moore Coulomb gave the concept of a straight line. Okay, but later Moore, he said that the failure curve is not a linear curve. It is a non-linear curve. Initially, it has a high gradient, and later on, it shallows down. Okay, and this kind of nature was observed by many scientific observations by many researchers, and based on those curves, a lot of people have given their failure criteria. Right. So here for the analysis as per the ISRM method, what you need to know is that your curve is given by sigma 1 is equal to 2c by cos phi by 1 minus sin phi plus sigma 3 times this value. This is giving you the equation of the curve. Okay, suppose you make this as b and this second term as m. So you can find the linear regression using Excel. So fx is equal to, that means sigma 1 is equal to 4.28 sigma 3 plus 50. So your b is the intercept, B intercept is 50.82. So B is equal to 50.82 I have kept here. And M is equal to 4.28. M is equal to 4.28 with this equation. Okay. Now here you see here M is equal to 4.28. So using component and dividendo you can find the value of sine phi. And once you know the value of sine phi, you can take its inverse to find the value of phi, that is the internal angle of friction. And that value turns out to be 38.4 degrees. You can check the calculations. I will share this Excel to you. Okay. So once phi is known, so put this value phi here, and this B is equal to 50.82. You can find the value of C. So your apparent cohesion is 12.8 MPa. Okay, so this is the way the linear regression is carried out, and you find the C and phi. These are the failure criteria, Moore-Coulomb failure criteria parameters. Okay, so in a triaxial experiment, you are supposed to find only C and phi. Okay. Although it is non-linear, you have to approximate it to a straight line. Okay, and here even at this confining stress up to 5 MPa, it is R square is 0.92. Now, if the same data can be utilized for another failure criteria that is given by Hook and Brown. Okay, Hook and Brown, he gave the equation of the failure criteria curve as sigma 1 is equal to sigma 3 plus sigma Ci is the compressive strength. Okay, Mi is the parameter of the curve. Sigma 3 or sigma Ci plus 1 power 0.5. Okay, now if you want to carry out the regression, this equation can be linearized if you take sigma 1 minus sigma 3 this side. Okay, and so this becomes a square. Okay, so m sigma y will be mx and c will be sigma 3. X will be sigma 3. Okay, c is equal to sigma ci square. Okay, so what we have done is we have taken these 4 points. Okay, from the previous experiment only, right? And then we have carried out the regression from this. Okay, and in this equation, what are the constants? The two constants are sigma ci and mi. Okay, so that can be calculated from this equation as m as 7.82 and sigma ci as 50.36. Okay, so this is the way you can do the regression for Hook and Brown. Okay, and for Moore-Coulomb, in this Moore-Coulomb, your equation is this: sigma 1 is equal to 4.28x plus 50.82. Now, from this equation, can you say what is the compressive strength of the rock? Uniaxial compressive strength?
Sir, 2c cos pi by 1 minus sin phi, sir. 50.82, sir.
Yes. Your sigma 1 is equal to 4.28 sigma 3 plus 50.82. So, in an uniaxial compressive strength, sigma 3 is equal to 0. So when you put sigma 3 is equal to 0, these terms cancel out. So UCS will be equal to 50.82. So with the Moore Coulomb failure criteria, what UCS you are getting is 50.82, and let us see what Hook and Brown is giving, 50.36. So this is 50.36 and this is 50.82, more or less same. Okay. So this is the way you can do the curve fitting, and if some complicated formulae for different researchers are given, then of course you can carry out the nonlinear regression, and then you can find out the curve for the failure. So these are the two examples through which I have shown you how to utilize it for the Moore Coulomb failure criteria. One sheet, another sheet, how to utilize it for Hook and Brown failure criteria. Okay, so this completes the discussion today. And of course, if you have to see the use the standards के हिसाब से कुछ चीजें important है. Okay, and the important thing is again surface pattern, कितना grounding होना चाहिए, spherical seating होना चाहिए, rate of loading is important, hydraulic pump का और pressure intensifiers का जो ये है कैपेसिटी कितने परसेंटेज में परमिसिबल रहेगा. ओके, कोर स्पेसिमेन 2 to 3 जो है रेशियो. ओके, हाइट टू डाया रेशियो preferably 54 mm, flatness of the specimen, all those things have to be maintained as per the IS standard. And again, the rate of loading is again an important thing that you have to take into account. Okay, and this calculation using the Coulomb's failure theory, okay, is this. Right. In fact, I told you Moore Coulomb. It's strictly speaking, it is Coulomb theory. Loosely, people sometimes say that it is Moore Coulomb. Okay, when we see the failure criteria, then we will understand. You will understand what was the Moore theory and what was the Coulomb's modification. Okay, so it's a loose speaking of saying Moore Coulomb theory. Strictly speaking, it is Coulomb's failure criteria. Any query, any doubt? If you have, we can discuss.
Sir, have we taken B equal to 50.82, sir?
50.82, this one.
Yes, sir.
Sigma 1 versus sigma 3. This equation is sigma 1 is equal to 4.28 sigma 3 plus 50.82. So your intercept is 50.82. Okay. So that means what is this coordinate? Coordinate A. A is equal to 0, comma 50.82, isn't it?
Yes, sir. Yes, sir.
Okay. So at 0, comma 50.82, what is the configuration of your specimen? Sigma 1 is equal to 50.82 and confining stress sigma 3 is equal to 0, isn't it? Sigma 3 is equal to 0
Yes,
at point A. Okay.
Sir, we got that 50.82 value at 1 megapascal confining pressure, right? No.
No. What is that?
At 0.
0. From this equation, what we are getting? 50.82. This is the equation, no? So when sigma 3 is equal to 0, sigma 1 is equal to 4.28 into 0 plus 50.82 is equal to 50.82. This value we have not got from the experiment. We are getting it from the equation. Is that clear?
Yes, sir. And sir, can you explain this cohesion and angle of internal friction? Sir, cohesion we take from this failure envelope where it touching y-axis. Right?
See, cohesion when you are using tau versus sigma, then tau is equal to C plus sigma and tan phi.
Okay.
Okay, and when you are using sigma 1 versus sigma 3, okay, then this is known as B and this is known as M. Okay, and sigma 1 is equal to B plus M sigma 3, and B is equal to 2C cos phi by 1 minus sin phi, यही है, and M
Yes, sir.
is equal to 1
Yes, sir.
plus
Yes.
sin phi by 1 minus sin phi. Okay, so this is known as your apparent cohesion. Triaxial test. Okay, and this tau versus sigma what you use is basically done for direct shear test. Is it there in your syllabus? Let me check. File, export as PDF. डायरेक्ट shear टेस्ट है क्या आप लोग का सिलेबस में? Probably it is there. Shear strength of jointed rock. Okay, so in the direct shear test, instead of using this sigma 1 versus sigma 3, we will use this equation, tau is equal to C plus sigma and tan phi. Okay, and here this is known as the cohesion. Okay, and this is the internal angle of friction. Right? Anything more?
Sir, wow. Once more, please. Angle of internal friction. I couldn't find the pointer.
Angle of internal friction. क्या क्या डाउट आ रहा है? What you want to
Sir,
know?
how can we define angle of internal friction and
Okay.
how it relates to this one?
How you see the question normally comes is internal angle of internal friction same as the angle of the repose also. ये आता है. Suppose you have a granular material, okay, and if you make it a heap, so this is going to make an angle theta. Okay, so that is known as the angle of repose. Okay, but angle of internal friction is not equal to the angle of repose. One thing. Another, angle of internal friction, it is an inherent property of the rock material. In fact, for soil also, you can find angle of internal friction. Okay, for that there is a separate setup. Okay, so for soil also, angle of internal friction is not equal to the angle of repose. Angle of repose, theta is from horizontal or vertical? Let me check. I've written down angle of repose. angle of repose, it is from horizontal only, right? Are you able to correlate now? And angle of internal friction is related to failure criteria of rock. Okay, and that is determined from tau versus sigma n, or from the tau sigma 1 versus sigma 3 curve. Here you find it angle of repose directly. Am I able to make any sense?
Yes, sir. Okay, sir.
Or you wanted to know something different?
Okay, sir. Okay, clear.
Has it made any sense, or uh, what exactly you wanted to know?
Sir, I didn't ask you about angle of repose, but actually, what means angle of internal friction? Angle of internal
So
friction only I asked about.
it is an inherent property of a rock material.
Sir, from graph, can we know it directly where it can find, like m value?
Yeah, few of the rock mass classification systems we have studied, in which you are able to correlate C and 5. Okay. You are from MTech mining or MTech trust?
Mining, sir. Mining.
माइनिंग, अरे ऐसा क्वेश्चन कैसे पूछ दिया भाई? पढ़ाया है पूरा, रॉक मास क्लासिफिकेशन भूल गया? CN5 निकाल सकते हैं? You can find CN5 from rock mass classification also. सॉइल रॉक देखकर और उसका कैरेक्टराइजेशन करके आ गया। क्या जी क्विज दे के सब भूल जाते हो क्या? ओनली अप टू क्विज यू आर एबल टू रिमेम्बर। प्रजाति के बाद क्या था? आरक्यूडी था, फिर आरएमआर आया था ना, इसके बाद आरएसआर था। आरएसआर में नहीं निकाल पाया। रॉक मास रेटिंग, when you are able to find rock mass rating, people have tried to correlate RMR with CN5. दिया है क्या? Table, I think I had given the table. See, you can utilize these values to find ये friction angle. Friction angle, this is the way you can find out friction angle or the angle of internal friction. Okay.
Okay, sir. Okay.
एक
Thank you.
कोलिजन का भी था। बार्टन्स क्यू सिस्टम में भी है कुछ। You have to, you don't need to remember the table. You have to remember what is given inside this table. That is more important. सी बार्टन ने भी दे दिया था C और 5 के लिए। Got it? So after seeing
Yes,
these
sir.
rocks, you can use this classification for rock mass rock mass C and 5. But whatever we have determined is basically our C and 5 of the intact rock in the laboratory.
सर इंटरनल फ्रिक्शन एंगल हम लोग फेलियर प्लेन से डायरेक्टली मेजरमेंट नहीं कर सकते क्या सर?
फेलियर से मेजर कर सकते हैं, फेलियर से भी मेजर कर सकते हैं। उसका आपको दिखाना पड़ेगा, एक कहाँ से ले सकते हो आप? कहाँ गया? लास्ट कौन सा है? यही है। beta is equal to pi by 4 plus pi by 2. This is the thing what you get from your failure criteria. Okay, and this beta को हमने डिफाइन किया है कहीं, tan square beta is equal to 1 plus sin phi by 1 minus sin phi. ओके, सो वहां से अगर आप जो फेलियर निकाल लिए हो, ओके, सो फ्रॉम दैट यू कैन फाइंड इट एज ये एक्सपेरिमेंट से बीटा और आपका ये निकल रहा है, बनाया है क्या, it is not there. So you can use that formula, beta is equal to pi by 4 plus pi by 2. Okay, so from the failure criteria pi by 2 का phi का estimate आपको मिल जाएगा. But then ये जो आप निकाल रहे हो ना, इससे तो आप सिग्मा 1 और सिग्मा 3 अगर आपका मिल गया है तो यू कैन ड्रॉ ऑलवेज, यू कैन ऑलवेज पेन कहाँ चला गया ये भी, इसके अंदर सिग्मा 1 और सिग्मा 3 आपका मिल गया है. तो उससे आप मोर सर्किल्स बना सकते हो, डिफरेंट मोर सर्किल्स फॉर डिफरेंट फेलियर्स.
यस सर.
ओके, इससे आप डिफरेंट मोर सर्किल्स बना लिए. ठीक है, तो ये क्या देता है, टाउ देता है और ये सिग्मा देता है. अब इसमें से जो एक एक का फेलियर प्लेन है, यही सब बीटा है ना, और फिर इसका जो ये जो कर्व्स है, फेलियर कर्व्स, ये सारे पॉइंट को आप जोड़कर फिर एक कर्व निकाल लेते हो, एंड दैट इज टाउ इज इक्वल टू c plus sigma and tan phi. This way also you can find the failure criteria. तो अब एक एक सैंपल में आप ये देखोगे, कूलम फेलियर क्राइटेरिया में ऑल दिस बीटा विल बी सेम. ओके, बट मोर ने जो मॉडिफिकेशन दिया था उसमें वो बोल रहा है कि भैया ये सारे बीटा जो है पहले बहुत स्टीप होते हैं, फिर बाद में वो शैलो होते जा रहे हैं, तो फिर ईच एंड एवरी फेल्योर के साथ अब बीटा डिफरेंट आ रहा है. बट मोर का जो ये था हाइपोथेसिस था, उसके हिसाब से ऑल दिस बीटा आर सेम. तो मोर के हाइपोथेसिस से आप जाओगे तो वो जो बीटा आप निकाल रहे हो फेलियर में, यही एंगल बीटा है ना, ये दोनों बीटा एक ही होता है. अगर फेलियर में दोनों अलग आया तो दोनों का एवरेज ले लो आप, एंड दिस इज योर बीटा. तो बीटा इज इक्वल टू क्या था, पाई बाई 4 प्लस 5/2.
यस सर.
तो बीटा आप एक्सपेरिमेंट से निकाल लिए, फाई यहाँ से निकाल लो आप, फाई को एस्टिमेट कर लो, एक सैंपल से मिला है तो. हाँ, लेकिन जब आप टेस्ट करोगे ना, सो ऑल दिस बीटा विल बी डिफरेंट. Okay, and your curve is never a linear curve, it is a non-linear curve. That is why the standard says कि आप at least 5 specimen test करो, and then you take the regression, and then you apply whatever failure criteria you want to make. So did I make a sense or it was a nonsense? यही पूछना चाह रहे थे आप?
यस. यस सर. यस.
ओके, ओके, गुड, नाइस क्वेश्चन.
So I had one question. In this experiment, we used the confining fluid as oil. So can we use water as well?
Yeah, you can very well use water, but water pumps are a very costly thing because when you use water with a pump, all your material has to be of stainless steel grade, and it becomes costly to maintain the parts of the pump. That's why people go for hydraulic oils because they will not allow the material to rust.
Okay, sir. And can the results vary with the change in the confining fluid?
No, no, it's a confinement pressure. It's not going to vary.
Okay, sir. Thank you.
Right? When I will be teaching this stress, strain, and the failure, those who are interested, those from MTech Trust, those who are interested, you can join my class. I don't have any issue. Those things are, those documents, whichever I have shown related to the failure criteria, that will be taught in the future classes. Okay, but when you are dealing with, say, failure of rock, if you have missed the yeah, stress strain part, it will become difficult for you to understand again. Okay, so the prerequisite for understanding this failure is again understanding of the analysis of stress and strain. Okay, anybody wants to join, you can use the link, ask the link from your friends, you can join. I don't have any issue. Okay.
सर फाइल में ग्राफ दोनों का फेलियर सीरीज के लगाना है।
फाइल में देख लो, सीख लो, आप बना लो, एक का भी चलेगा, बट यू मस्ट अंडरस्टैंड हाउ दिस हुक एंड ब्राउन फेलियर क्राइटेरिया का जो ये सॉफ्टवेयर जो आप लोग यूज करोगे. Okay, I think is having a software. When you are back to campus, you can use the रॉक साइंस सॉफ्टवेयर. ओके, और रॉक साइंस सॉफ्टवेयर में जो निकाला है उन्होंने, जो निकालते हैं वो लोग M and S parameter, M and sigma pi parameter, they do it by their calculation in the software. Okay, and that software is very similar to what we have done in Excel. बहुत ज़्यादा सेव हो गया, कि इसको भी सेव कर दूं. Discussion, save as discussions. Experiment discussions. Any more thing you want to know? Okay, fine.
अटेंडेंस को
अटेंडेंस तो दे दिए थे जी. सिद्धार्थ उर्मिलिया एब्सेंट था क्या? कब ज्वाइन किए?
सर तुरंत आ गया था अटेंडेंस के बाद सर.
इतना लेट क्यों करते हो जी? 10 मिनट बाद अटेंडेंस. और किसी का है? मांडलिक प्रज्वल, चेतन अजमेरा, आशीष तिवारी.
सर चेतन अजमेरा।
और ये दोनों मांडलिक प्रज्वल नहीं है. ठीक,
थैंक यू सर.
ठीक है. ओके, Thank you all for joining today.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir, will we get your handwritten notes to read or refer to?
No, I have not written any handwritten notes. You have to use
No,
it.
the one that we saw now in this practicals.
Which handwritten note? These things.
Discussion,
Yeah,
sir. Discussion.
Discussions. These things.
The
Failure
acceleration
criteria.
part, stress related, everything that you have written.
Wait. Which one
The
you
notes,
want? I will give
the
you.
notes that you
I'll save
showed
it
of
now.
your
Wait.
geomechanics.
See. Tell me which one you want. I'll save it on the desktop so that
Okay,
I can upload it. One that that I have shown it to you for case equation that you want.
Yes, sir. Yes.
Wait. फेलियर क्राइटेरिया भी चाहिए.
Yes, sir. Will do.
फेलियर क्राइटेरिया दे देता हूँ. फाइल सेव ए कॉपी डेस्कटॉप. फेलियर क्राइटेरिया दे दिया. That kills equation, no? Before in-situ stress normally deal this. Okay.
Yes,
One more thing I will give you. Wait, I will show you how you do regression with hand. अभी दिखाता है. अच्छा ये प्रॉब्लम हो गया था. Regression का somewhere some notes I had given to the students. है क्या? No, it's not there. Okay, if I find that document, I'll give you. Okay, so this is the two documents you wanted: failure criteria and the case equation, right?
yes, sir.
Okay, fine.
Okay, sir. Thank you.
Thank you.
Thank you, sir.